Undoubtedly, the era of high-speed 3D printing is here. Every printer company seems to be coming out with their own take on one of these ultra-fast machines, and there's probably no one better known in this space right now than Bambu Lab. But what if there was another machine that not only could be an equally powerful option to these Bambu Lab printers, but could also surpass it and at a lower cost? That's exactly what we're going to be looking at today with this printer. I am so excited about this video because, as you can see, we have a brand new 3D printer to try out. This is the Keedy X Plus 3. It is a fully enclosed, ultra-fast Core XY printer that runs Clipper and claims to be able to print up to 600 millimeters a second. I know, that was a lot, and I really don't want the rest of this video to be too statistic heavy. I know that can get very overwhelming very fast, and when it comes down to it, the most important thing is if the printer ends up working well for the projects you're wanting to make using it. For me, that's going to be looking at how this machine works for building life-size prop replicas. And droids, which I'm sure for a lot of you here, those are the types of projects that you're mostly interested in as well. Now, the Keedy team very kindly sent over this printer. They were basically like, we have this new machine coming out, can we send you one to see what kinds of things you can build using it? And the specs on this thing sound absolutely incredible, so I had to say yes. I'm not being paid to make this review video, so all opinions in it will be my own, completely unfiltered. So with all that being said, let's finally start unboxing this thing. While I'm getting this printer out of the box, let's talk about some of the specifics of this machine. The Keedy X Plus 3 has a build volume of 280 by 280 by 270 millimeters, which, to put it in perspective, is larger than any of the Bambu Lab machines, which come in at 256 millimeters cubed. It can also print faster and hotter than the Bambu Lab printers, with a max speed of 600 millimeters a second and an extruder that can reach 350 degrees Celsius. It has a direct drive extruder and actually comes with multiple hot ends. The copper hot end comes pre-installed on the printer, but they also include a hardened steel nozzle and hot end assembly for any abrasive filaments like carbon fiber, glass, etc. Another incredible bonus feature is that it has an independent chamber heater that can reach up to 65 degrees Celsius. That's going to make any harder to print filaments that much easier to work with. It also uses a magnetic flex plate, has a filament sensor, a touchscreen, and automatic bed leveling. And setup for this machine was super simple. It had everything packaged inside of the printer. Here you can see me unboxing the tools and accessory box. It comes with a lot of the typical maintenance tools that most 3D printers come with: Allen keys, a wrench, a screwdriver, scraper. This box also had the extra nozzle assembly, rubber feet, and filament holder. But now let's start getting this printer actually up and running. The instruction booklet that it comes with is actually quite helpful and detailed, something that a lot of printers do not seem to have, but a cool thing is the printer itself will actually guide you through all of the same steps. So very user-friendly. You're mostly just taking stuff out of this machine, taking all of these zip ties out, any packaging material. There's a collection of 4 screws actually attaching the build plate to the bottom of the main printer frame that you have to remove. But after that, that is the last sort of pre-setup step before you can go ahead and start leveling the bed. It comes with this special plasticized print card that you place under the nozzle in one location, do the very common friction test so you can set the Z offset, and after that the print bed will automatically level itself. It probes 16 points across the build surface, and once it's finished that, it then starts input shaping, which from this footage looks like it's doing absolutely nothing. But what input shaping is it's making the machine vibrate at different frequencies, so then it can appropriately counteract any of those vibrations so that they don't show up on the print surface. It sounds pretty insane when it's doing this though. The one and only assembly part of this setup is attaching the filament drawing box and spool holder. Of course, straight off the bat, we have to talk about the location of the spool holder, amongst other things, on the back of the machine. I understand why, in theory, this would make sense in every other way than when it comes to user experience. Thankfully, though, it doesn't have to become a massive issue. There are actually quite a few alternative filament roll holders that Keedy has featured on their site that you can print to change the location of where the filament is stored. Before I went and got anything printing, I first updated the firmware, which it's always a good idea to check to see if there's any newer firmware available for a brand new printer. You never know how long it's been in its box and what kind of updates have happened since then. So now that everything is out of the box, packaging is all taken out, which really was the main preparation work for this. You really don't put anything together, you mostly just take stuff out of it that's put in there for safety during traveling. Firmware's been updated, all of the bed leveling, input shaping, all of the preparation is done. I think it's time to slice something and actually get something printing on this machine. I decided to use Kitty's own slicer, but they do have machine profiles for a bunch of the other popular slicers. I wanted to give theirs a try and see if it made anything go more smoothly. It's actually derived from Prusa Slicer, which I don't have a ton of experience using, so this was basically learning how to use an entirely new program, but I found it pretty simple to figure out. A lot of people use a Benchy as their first print, but I have not once in my many years of 3D printing printed a Benchy, and I was not about to break my streak now, so I chose this Lothcat file instead. For this print, and actually for the rest of this video, the only settings I made changes to were playing around with some of the speed settings and changing the temperature and fans to better suit the filament that I was using. The retraction flow, all of that seemed to be perfectly dialed in at their default values. I really don't think any of this printer footage can truly accurately capture just how fast this machine would be moving. I could just sit and watch ultra-fast printers work for hours. It's mesmerizing. The Lothcat I printed in this gray PLA Plus filament, it's one that I've had a lot of experience with, so I figured it would work well for this first print. This looks absolutely incredible. It took just under 2 hours to print, and honestly, this thing probably looks better than any of my other printers, even though it's going like more than 3 times as fast. It's insane. And this isn't even close to as fast as it apparently can go. I did not mess with the speed settings at all. It was put into like normal mode in the slicer. I know all of the support materials are still on it, but I really just wanted to show you what it looked like straight off of the build plate. There's a little bit of stringing just by the ears in any of the places where there was like fine details, but like look at how perfect the point of that tail is. I know that none of my other printers would have been able to do that. But yeah, other than the little bits of stringing, which honestly could just be down to I might be printing this filament a little hotter, I was being a bit conservative with the temperature because I know having things be able to melt fast enough is a big issue with really high-speed printers, so maybe it's a little too hot for this filament, but the stringing is really minimal and it's really only on these like really fine jumping point details. Like even between the tail, it would have jumped between the tail and the body. There's absolutely no stringing on the body whatsoever. It's just really on these cone point shapes. I did have a minor casualty in the form of a lost front paw, but that was very much user error. But yeah, I think for a first print and something that has admittedly quite a bit of fine detail, this looks pretty excellent. Some of these surfaces are a bit rough. Me removing it in a not great way didn't help matters, but since this was quite the successful test build, I think it's time for bigger and more exciting things. So I have spent the last week and a half printing pretty much 24/7 to get as much mileage out of this printer as possible, and as you can see, it's been a very productive week. This isn't even actually everything I've printed, this is just what could fit on the desk. Now that I've gotten a couple hundred hours of printing experience with this machine, I feel much more qualified to be able to sit down and actually talk about this printer, and of course also share what exactly it's been printing over this last week plus. Of course, the first real project that I sliced up for the X+3 was this B1 head, which first of all, any of these projects that are in separate pieces, none of them are glued together, so if anything looks like it's not quite fitting right, it's because it's all just pressure fit. This B1 head does have a few bolts in the neck parts, just because I could easily remove those later, and some of these back head pieces have some poster tack just to hold them on because, you know, gravity's a thing. But most of these head pieces are just being held together by the dowels. You can see, I mean, it does fit nice and snug, which is why it it's staying together, but it also can come off quite easily. The main section of this B1 head was what was part of the very first build plate. I believe there were 2 or 3 different build plates to complete the main head structure, and then the base I printed later. The gray is PLA+, the black is just normal PLA. So for a nearly first print, other than just the base Lothcat test, these pieces look pretty incredible. There really is not much wrong that's going on here. I ended up adjusting the temperature a little bit, but overall, the paneling detail on this headpiece, it pretty much could not get more perfect. All of the support material came off super easily, everything fit together really nicely, and just the overall surface of the filament looks really, really nice. So because it was such a successful first print, the only thing I really tweaked was the temperature, because it kind of looked like it was printing a bit too hot with some of the outer lines of the surface, but really nothing too dramatic. So since all of those settings seemed to be working well, I then ran off and sliced up the neck pieces and the head back detail pieces, and that is where the first sort of issue happened. Now, I want to preface this by saying I fully believe this is more of a user issue and not inherently a machine problem. So the first round of neck prints that I did, there were dowels that I put on the build plate as well, and those came off of the build plate, which, you know, is a very sort of typical thing that ends up happening. They're quite thin. It's one of those things that it's sort of a hit or miss as to whether the nozzle might accidentally knock those off or whatever. So for whatever reason, the dowels themselves failed to print, and that's also what I thought originally caused the strange situation of the corner of the build plate actually lifting. So these neck pieces, as you can see, are quite long, and I'd angled them diagonally across the build plate, and they'd actually lifted the corners of the magnetic plate away from the magnet, which is not something that I've ever experienced with magnetic plates. All of my machines now have them, and so that was a bit unusual. So I thought it might have been, you know, just something weird had happened with, you know, the failure of the dowels. It might have messed up the print job itself, and so I ran that off again, and the exact same thing happened. Now, I am not one for wasting a lot of plastic, so because it happened twice, I just wanted to see, for experiment reasons, what printing the neck pieces in the exact same fashion on one of my other machines would do, and I did that. It went fine. There was no lifting of the bed edges. My printer decided to somewhat hate me and did a little bit of under extrusion, so they're not the best looking pieces ever at the first few layers, but the overall test was more that they did not lift the bed at all whatsoever. So I thought it was maybe a magnet issue, like it was just a weird thing that happened that I wasn't exactly sure why. But now that I have had many more hours of printing experience with this machine, I do actually think I know why. And it is essentially all of these parts are overcooled. The head, of course, was not going to be the best test to find out if this was an issue because it's quite a chunky piece, and overall, the layers seem to be adhering fine to themselves. But some of these smaller pieces, I have a feeling that if I really tried to snap it, it would snap. They're not the most structurally sound, which is completely my fault. I just let the base settings for PLA stay, and there's a lot of fans in this machine. You have the parts cooling fan, you have the chamber fan, and there's another fan that I forget what the name is. But there are 3 fans in this machine, and it just seems like it's cooling the plastic too efficiently. That also might have something to do with I'm in a basement workshop. It's not particularly warm down here, so if you were in warmer climates where the ambient temperature of the machine was higher, then you might need to up the cooling of the fans, like the percentage that they're running at. But it's something that I know now. I didn't want to run off this print job again because overall I think this is going to be fine for a display piece, but it's a brand new machine. It's going to be a learning experience for what would technically be considered a failure of a print because of the overcooling. It looks pretty incredible. I think we can all agree with that. The base itself was also printed with the overcooling issue because I did them back to back to back constantly without realizing this was actually an issue I should be concerned about. But overall, for a first print with some issues that were completely self-inflicted, unfortunately, a very nice looking display piece. After I got all of those pieces printed, I wanted to try something with a finer detail, so I ran off this pit droid sign. This was printed with a 0.12 millimeter layer height. Everything else was 0.2 millimeters. I did not stray from that after this piece. Not that there's anything particularly wrong with this piece, it's just 0.2 layer height was going to work perfectly fine for all of the other pieces I was planning on printing off, so I just didn't really feel the need to lower the layer height. But for this, I wanted to see how it would handle, and it does look like it was a bit of over extrusion, or at least maybe a bit too many top surface layers. So it has a bit of that rough texture that you get when there's like too much filament in the one area. So again, that was a settings tweak, but overall the details on this look really nice. Even though this again has the overcooling issue, it's probably not going to be a structural problem since this is quite a flat piece, and it would be the structural integrity this way that would be an issue. So overall, not the best looking print that I've ever seen, but something that could definitely be improved upon with tweaking a few slicer settings. Now, the only other PLA piece in all of these print jobs was this. Now, this I did much later on in all of these print jobs, and at this point I did realize that there was probably an overcooling issue. So this was printed with 100% of the hot end fan and 30% of the parts cooling fan, I believe it's called. I really should have looked this up before I started going on about these fans. When these were printed, it was 100% for all three. This was 100% for the hot end fan, 30% for the other, and then 0 for the last one. So this was printed like this with no supports. It has these overhang areas that are a bit rough. They're not terrible. Again, something that could be tweaked with settings, but this is definitely getting closer to what my PLA settings should be on that machine. This is solid as anything. It is also one of the just cleanest looking PLA pieces I think I've ever printed off. It does not even look 3D printed. This is a vat storage, by the way, for a resin printer. I didn't have one for my Mars 3, and I figured why not have this machine pull it off, and then I could test out my theory towards the cooling fans, and it was correct. This is significantly better. You can see the color and like texture difference between this base and this piece. It is the exact same filament. This is incredibly matte, and this has ever so slight sheen. It's still like quite like a matte satin finish, but it is a lot shinier than that base. A simple piece, but a very nice looking one that of course is going to be very useful for me in the future. Next, we need to talk about these. I'd always planned on doing a direct comparison between the X+3 and one of my other printers to see what the time difference would be for the print job, if there was difference in, surface quality, just overall see how the experience went with two vastly different printers printing the same file, and just see how that went. So I chose a Phase 1 Clone Trooper helmet for this, which yes, the X+3 can basically print a full-scale helmet. These have the dome parts separated. The thing that I kept on running into is these machines are always more of like a cube dimension, whereas the open frame bed slinger type printers like a CR10S or Ender 3, they have a higher height, so on the Z axis. This printer isn't quite tall enough to be able to print a whole helmet in this direction, but that was not an issue for this particular file because the dome part itself could become its own separate piece, which was awesome. Which honestly, even being able to print this in one piece on my CR10S, I might have preferred to have printed it in these two pieces anyhow, just to avoid any possible print failures, and it's going to be a really easy attachment later when I finish these. So this is the one that I printed on my CR10S, and this is the first one that I printed on the X+3. Or I should say, the first one that successfully finished printing on the X+3, which this again was a completely avoidable situation that was brought on by my inexperience with the machine. But I do want to go over everything that happened in the last week and a half, so if you are somebody that owns this machine or are considering owning this machine, you know all of these little learning experiences beforehand so that you yourself can avoid them. So this, I believe, was what was actually my first print attempt on the X+3 for the bottom part of this Phase 1 Clone Trooper helmet. And this had a lot of unnecessary support material. I kind of messed up the support material slicer settings. Ideally, you have the overhang set to 0, and then the slicer will place the supports in the most ideal location. I had it set to whatever my usual was, like 65 degrees or something, and it put it a bunch of places that were significantly less than 65-degree overhangs. This had a lot of unnecessary supports, and they were failing on it, which then ended up somehow messing up the entire print job. I had a whole spaghetti situation happen, and so I canceled this print job. But other than the fact that this, I could quite easily, like, you can hear it giving up. You can see the crack that I just made in the side there. You can see the crack here. The layers are just not adhered to each other, like, at all. If I went to sand this, it would probably fall apart in my arms from just the maneuvering that you'd have to do with the sanding process. But I still, at this point, thought that the issue was only the support material and not the excessive cooling. So I ran it off again, which is this quite short piece. And this is when I found out the hard way that the filament sensor is not necessarily turned on automatically. I believe once you do turn it on, it will stay on if you turn your machine on and off, but I was flipping out the different filaments at various points, and so when that happens, I believe it turns itself off because of course you're removing filament, it senses there's nothing there, and I don't think it turns itself back on. Again, very much a user error. I do wish that there would maybe be something on the print screen that would like say if the filament sensor was on and off so that you would be aware if it was on or off, or, you know, could turn it on from the print menu. I'm not entirely sure if you go to actually like pause it if that option comes up. I can't quite remember, but just having it more visible to know if the filament runout sensor is on or off would be nice from the printing screen. But of course that was again a completely avoidable mistake that was mostly my fault. And that brings us to this helmet. This was the successful PETG print on the X Plus 3. And this is when I did fully realize that there was an overcooling issue, because I was just generally testing the strength, because at this point I kind of wondered if that was maybe what was happening with all of these print jobs, and I poked around and I could very easily pull, you know, the various parts off. So that is unfortunate that, you know, both of these pieces are quite delicate. Because they printed successfully, I'm going to try and work with them gently and finish them up, because this is a lot of plastic. It is overall a perfectly fine print, and as long as I'm more careful with finishing it, it should be fine, and I'm not going to complain about having another Clone Trooper helmet. So that is the story of why there are 3 helmets. Now I believe the one and only issue that I experienced the entirety of these hours of printing happened during this Clone Trooper drama as well. So it was one little hiccup that sort of compiled into 3, all very easy fixable issues that, again, want to mention here just so the information is out there. And I just want to point out, this printer prints so fast that all of these issues were within like the first 3 days of me owning this printer. So all of these learning experiences were quite early on. Like 3 days owning a printer is no time at all. And you know, even a week and a half at now, I feel so much more comfortable with this machine. It is a very short space of time. So there very well could be even more that I figure out and learn about this printer and how to use it to its most optimal settings. But within this very early on stage and mid-clone drama situation, the one and only actual machine issue happened to me. I went to go start a print job and the printer head actually lost its position. Now, I hadn't realized it had done this until it had like slammed into the side of the machine, which made an atrocious noise and, you know, fully did freak me out, since this was like the 4th day of owning this printer. Which, one thing to know about the X Plus 3 is it does not actually have any X or Y sensors. It only has the bed probe. So if it loses its position, it quite literally doesn't know where it is. Of course, when it started making this atrocious noise, I shut the machine off, did some research, sort of looked at the printer, tried to figure out what the problem was, and what I realized is that the rails that the extruder is on, it was like bound to the extruder. Like, it was not moving at all, and because it like couldn't move on the rails, that's what made it lose position. Now, when I got the printer, I never checked to make sure that the rails were actually lubricated appropriately. I just sort of assumed that they were. It was out of the box, brand new, so I'm not sure if it was more from like a storage situation or it's just something that you need to be lubricating the rails much more frequently than in other printers' cases. But thankfully, the other axis rails were not as bad, so that I could actually see that it was the problem. Like, I didn't know if the machine just sort of halted itself where you couldn't move the print head around when it was turned off, because like that is how much the print head was stuck. So once I realized that, I did clean off the rails, re-lubricate them, very much had to like shove the print head along, but eventually everything was in like a perfect working order. It was a nice smooth glide all over. But when this was happening, it triggered, or I'm assuming it triggered, the one error message that I ever got from this printer. I will put it here now. I had no clue what this problem was, so I like was furiously Googling, because again, I thought I'd like doomed myself big time. It is not the most uncommon error, and it's also not a humongous deal. It's unfortunate that it happened. It is an error that comes up when the print head doesn't communicate with the rest of the motherboard, essentially. This printer actually has a USB-C cable that goes from the hot end extruder assembly to the motherboard, and this is the error that comes up when it loses communication through that USB cable. I did end up contacting the support email that is specifically for this printer, because originally I did not know what this error was or how to fix it, and they're actually going to be sending me a brand new USB-C cable to stop this issue from happening in the future. And that's not some like special treatment that I'm getting because I got this printer sent to me. That's just normal customer service. If you've got a problem, they're quite happy to send you replacement parts if it's any sort of thing that really should not be happening. It is of course unfortunate that something like that happened mid-print and did mess up another one of my reprinting clone parts, but it was not that difficult to fix, and you know, I have this new cable coming, but since I went into the hot end and really made sure that that USB-C cable was plugged in, that error has not come up. And so I'm just assuming that due to the smacking around of the printer losing its position, or just me having to like really force the hot end across the rails to re-lubricate everything, that is probably what made that cable loose to trigger that error. So between that error that messed up even more PETG prints on top of just me messing up my own PETG prints with the overcooling, I really just wanted to move on to a different type of filament. So I decided to bravely try ABS for the first time. So if you don't know, ABS is just one of those trickier to print with filaments. It has the habit of curling up and not sticking properly to itself when it's not printed in a hot enough environment. So this was a great opportunity for me to be able to test out the full enclosure aspect of the X+3. And so because I was much more aware of the fact that ABS really does not need much cooling at all, that is when I turned off basically all of the fans other than the hot end fan, which I believe does not run at 100%. I will insert my settings that I used here for ABS, but you're just being much more conservative with the cooling settings. And of course, because that was basically the main issue that had been happening with all of my prints, all of a sudden I'm getting all of these successful and just gorgeous prints in a filament that I was absolutely terrified of printing with because of how difficult it's supposed to work with. And so that brings us to this gorgeous specimen of a Clone Trooper helmet. This one is a 100% ABS print, and it is beautiful. The advantage to using ABS for prop pieces, other than its increased strength and heat resistance, is that it sands like a million times easier than PLA or PETG. So the fact that I got this incredible looking Clone Trooper helmet print finally, and it's also out of a much more difficult to work with material, this is when things really turned around for the better. So I really didn't mess too much with the support material so that you could be able to see sort of exactly how they came off of the print bed to compare them. Of course, unfortunately, this is now not an exact one-to-one comparison since this is now ABS and this one is still PETG. But like, I was so over all of the PETG drama that the ABS is fine. And you know, in theory, this should be the much more difficult print to get it looking at this level compared to PETG. Now, other than finally fixing the overcooling issues when I started printing with ABS, I also tweaked the speed settings because I was concerned that that might have also been contributing to the print failures that I was having. Now, somehow, even though I did essentially slow down various speed settings for ABS, it started printing faster. I do not understand it. I did not really mess with the support situation that I had between the PETG print and this ABS one, and even though I slowed it down, it somehow took 7 hours less between the two. So I'm not really sure what's happening there. I mean, I'm not mad about it. So of course, both of these helmets are printed in these two sort of main pieces. And so the dome piece on the CR10S, which is this piece, took 34 hours and 24 minutes. The dome piece out of ABS on the X Plus 3 took 10 hours and 43 minutes. So basically shaved a day off, and the rest of the helmet, which is, you know, practically the entire helmet, on the CR10S, it took 85 hours and 31 minutes, and out of ABS on the X Plus 3, it took 20 hours and 27 minutes. Now, I would not say this PETG helmet looks bad whatsoever. It's a very clean print. There are a few little issues here and there, but really nothing that I would be concerned about finishing and, you know, sanding. It's a very nice print. This one, however, it's like perfect. There are a few little ringing things, and also because this is ABS, ABS is prone to shrinking very fast, so it did pull away from the support material here on the front a bit. Again, something that I have since fixed with setting modifications. But other than that, the surface quality of this X Plus 3 one, it's just ever so slightly smoother. There's not as much variation in, it's not really ringing, it's just, you know, when you see the curve of the lines like on the helmet and stuff, you can kind of see the layer lines themselves, and there's just ever so slightly more on this one. But I mean, the main thing here is this one is printing in like a quarter of the time, and not only is it looking equally as good as the one that takes 4 times longer, it's actually looking better, which is insane to me. Because of course there could be that trade-off of all of a sudden, yes, you can print this piece faster, but because of that, you're then sacrificing surface quality. But yeah, I'm gonna give the X Plus 3 the just as good, if not even better, even though it's out of a more difficult material to print. And I should also mention, for this particular print, I wasn't using the chamber heater. So the X Plus 3 actually has a separate heater to heat the entire enclosure. So I was just using the passive heating that the build plate was mostly giving off. It's mostly going to be the build plate that's heating up the enclosure. And I found that the bed would keep the enclosure temperature around 40 degrees Celsius. Something that I did start though is if the machine had been off for a while and then I was wanting to print with ABS, to up that enclosure temperature to be more warm and not have to wait for the machine to be running for an hour or two maybe to finally rise the enclosure temperature up to the 40-degree mark. I was essentially preheating the enclosure up to that level, and then once it had hit that, turn it off and the enclosure would be able to maintain that temperature since the bed was then on and continuing to heat the enclosure. Now, as impressive as this ABS helmet is, it's not actually the very first print job that I did in ABS on the X Plus 3. Now, a lot of you I'm sure have already seen this helmet. I've already posted the finished video for it, but this is Captain Enoch's helmet from Ahsoka. So even though these were the first ABS pieces that I'd ever printed in my life, they turned out so much better than any of the other pieces that I'd been printing on the X Plus 3 so far. Again, it's probably got a lot to do with the fact that I fixed the overcooling issue, but I was thrilled that things were finally going incredibly smoothly. Like, could not have been going more smoothly with a filament that should have been giving me a headache. I wanted to finish this helmet project really fast, which is why I decided to print it in ABS, and I was not disappointed. I got this whole thing done in 48 hours. That included the print job. It was like 28 hours and some odd minutes for all of these pieces, and you can see it is like a full-size helmet, but this thing printed so perfectly, it sanded so perfectly that from this point on, I became an ABS printing fiend. I believe the first thing that I printed after I got all of these helmet pieces finished was this. This is of course Han Solo's head in carbonite. I did print the neck too, although it's not as impressive looking as the head itself, but I wanted to see how it would like printing more like a surface quality detail since it did print like this, and this thing looks awesome. I'm probably going to be making an entire Han in carbonite installation somewhere in my workshop or just outside of it, so figured I would get a head start with that, and it's such a recognizable thing, I thought it would make a cool printer test piece. I then went ahead and printed an entire droid, but this is the RJ83 droid. He has this really cool ball joint articulation, his little arms move, and he's just so cool, and this was a great test to see how the pieces were fitting together straight off of the print bed, and he just fits perfectly. I was printing all of these ABS pieces with brims just so that they didn't accidentally start curling up at the edges, and I did not have a single issue with lifting whatsoever from the build plate, and they also were basically just peeling off of the pieces, so really not a big deal cleanup wise afterwards as well. But he is such a cute little droid. He only took about 24 hours to print all of the pieces in, again, ABS, which I was not expecting to be printing so much in ABS. I did run out of gray ABS and had to flip to white, which is why you've got some like stripy parts here and there, but he looks really awesome. Can't wait to finish him up as well. So he was sort of like a light test for detail and just making sure that I had all of my ABS settings dialed in, and I think I do. There's maybe like a few little tweaks. I could possibly even look at speeding up some of the settings, although I personally think it's printing fast enough for my liking. There are a few pieces here and there that look like they might be over extruding just a touch on the upper layers, but overall it's just a very, very clean, perfect finish on all of these prints. Now, for my case of just perfect finishing quality are these pieces, which this is probably like the least exciting print out of all of them. This is Sabine's speeder bike helmet, but it's in separate pieces, so right now it really doesn't look like much. You have the ear pieces here. Just look how flawless the finish is on these curved helmet pieces. They practically don't even look 3D printed. It's so smooth and there's like no layer lines whatsoever. I then wanted to try printing something with a bit finer detail to see what those pieces would look like, since, you know, we're fully aware that it can print nice smooth surfaces no problem, but what is it like when it comes to fine detail at such a high speed? So I printed off these Calicori pieces that have a ton of intricate side paneling detail. I didn't print the entire Calicori because I didn't know how these would go, and so these are the largest pieces of the Calicori. When I was planning on originally making this file, I was fully looking at possibly printing the entire thing in resin, but I thought it might be an interesting test, especially for some of these larger pieces that wouldn't be as practical to resin print, and the detail on these is incredible. Of course, the surface finish is excellent because it's ABS and this machine is just great at printing. Fine triangle texture on the sides of this main piece, and it looks almost as flawless as a resin print. It is insane. All of the paneling details on these look perfect, but I'm incredibly impressed at the level of detail that these pieces have, and again at such a fast speed from an FDM printer, which even though I didn't actually go ahead and slice more, I could see printing even more of these Calicori pieces on this printer because it could handle the detail so well. And the final thing that I ended up printing, of course, again in ABS, was definitely the most risky of all of my prints. So this, again, I wanted to see how it would handle the detail, but the way that this training sword had to print was straight up like this. So this is in 4 parts. You can see them all there. It's being held together by some steel rods right now, but these pieces had to print upright like that, very little surface area on the bottom, very tall pieces, and multiple tall pieces on a print bed. I do not think that I would have been brave enough to attempt printing these on any of my other printers because the nozzle would just hit these pieces, knock it over, and it would be a catastrophe. And you would just never get these pieces printed. And it's not like you can really print them flat because they have this really gorgeous inlay detail along the blade and handle. So straight up and down is really the only option that you have for this particular model. But as you can see, because I'm holding this training sword in my hand, it finished perfectly. There was not a single issue. The detail on it is fantastic. It's just an incredibly gorgeous print. Again, this is one of those models that I thought that I would most likely be resin printing if I was going to print it on anything, but I thought, let's put it on the X Plus 3, see how it handles it, and it handled it beautifully. So final thoughts on the Keedy X Plus 3. You probably can guess that due to my sort of ranting and raving for the last however many minutes, I really love this printer. These are the best print jobs from an FDM printer I've ever personally gotten. Not only do they look better than anything else, they're also finishing so much faster, which is enabling me to be able to pull off projects like this helmet, for instance, in an incredibly short turnaround time. For the most part, out of a material that I would not be able to print easily on any of my other machines, forget at the speed that this printer can do them at. I am somebody that tends to need prints to be done fast, and I've been trying to slow myself down and realize that printers have significantly more time than I do to finish prints. So printing things at higher quality generally is the better idea because then you don't have to do as much work post-processing, which is where, you know, you yourself need the actual time to be able to do that. And so since this printer is printing so fast and at such a high quality, it is printing in a lot of cases probably at a higher rate than if I was to print something with a larger nozzle, or at the very least at the same rate. There is the whole, you know, mathematical equation of how much plastic it can output in the same amount of time if you were using a larger nozzle. But of course, at that point, the larger nozzle print jobs, they have less fine detail. The surface quality will technically be messier. It has larger layer lines generally, so it's just not as precise and clean of a print job. Like for large helmet projects, it works perfectly fine. You've seen me do lots of droid pieces with larger nozzles, and overall the prints can look great. It's just the finishing afterwards can sometimes take you longer, which isn't always great. So the X Plus 3 is really like matching my print attention span with the quality attention span that I want to have. That is why I could look at literally on a Friday morning deciding, oh, this weekend I want to work on this project, and by Saturday morning I could have all of those pieces printed and ready to work on. And that to me is incredibly valuable. It like matches up perfectly with my attention span for needing to work on a project right then and there, but then unfortunately having to wait for the pieces to print. Now, I fully assumed at some point I would most likely buy a Bamboo Lab printer, but honestly now I have no interest in doing so. I would much rather buy another X Plus 3 or even an X Max 3, which I'm honestly probably going to do because I love this printer so much, and the possibility of having two of them running would be absolutely game-changing for me. Since I'm primarily going to be looking at printing in ABS for my prop projects, I would need to be looking at an enclosed printer, which means I'd be looking at something like the X1 Carbon, which is more expensive than the X Plus 3 and also smaller. When you are someone that is typically printing life-size prop replicas, you want the largest print volume available in a lot of cases. Like not necessarily massive, but somewhere around the 300 millimeter mark is typically a good place to start. And when you start getting smaller, that is when things can start becoming an issue. A lot of pieces will start not being able to fit, which means you'll have to print things in multiple pieces, which then you need to assemble together, which is even more more of your time. So there really isn't a lot to draw me towards the smaller print size when I know I can get a bigger machine that prints things for me absolutely incredibly and is also less expensive. And of course now, because I do have a machine that can print ABS so successfully, I can start my life-size chopper build that I've wanted to do for years. But I think that wraps up all of my thoughts on the Keedy X+3. Again, thank you to Keedy for sending over this printer. It's been so fun using it the last couple of weeks and printing all of these incredible looking models that I cannot wait to start finishing. If you're interested in finding out even more information about the X+3 or are interested in any of the models that I've printed in this video, links to all of that will be in the description box. But that is everything. Thank you so much for watching, and I will see you in my next video.